So, good morning, good afternoon, or even good evening, again, depending on what time you choose to listen to this recording. So, today we come now to the fourth part of the equilibrium module, and we'll be ending the equilibrium module here. And we'll be talking about elasticity. And now, as I said, I've also will be putting up some videos on some extra examples on shifts on demand, and if given the time, I might be able to make another video as well to give you some more examples on elasticity. So today I'll only be showing you the concepts of elasticity, and then and I'll give you a few examples, but just to drill the concept in. But if you want some additional examples, I might be able to put up a video. It all depends on my schedule because it takes about a whole day to create these slides and about half a day to record the video. After which I celebrate playing a game of Skyrim or something like that. Of course, on my Samsung smart fridge. Of course, that's where you play Skyrim, right? Anyways, so our background for today is the Serengeti, which is in Tanzania. You might be wondering how in the world is talking about the savannah, the wildlife, part of economics. And indeed, it has actually a lot of implications when it comes to economics. Economics has a lot of implications on wildlife, and it will be a bit of a sobering thing today. This particular case study, when we talk about this later on, when we talk about poaching and the hunt for ivory. Okay, so sometimes economics takes us to dark places, and unfortunately, this is one of those times. But I'm here to show you the whole range of the stuff that we can analyze using economics. Okay, so to be honest with you, when it comes to elasticity, the usual thing that we talk about is the war on drugs. But I feel like that's something that we could do something else with elasticity. So we'll talk about poaching again. Not the best, not the happiest thing, but hopefully it'll help us at least to understand what the concepts are and its reality. Okay, so let's get started. So let's just have a recap on equilibriums and shifts, okay? And again, we've seen this slide before. So when we draw demand and supply curves, we always have quantity on the x-axis and price on the y-axis. This is like the nth time that we've had this, so I hope you know this by now. And then, of course, our supply curve is always upward sloping because law of supply, the more expensive a good is, the more suppliers will be willing to sell. And the demand curve is downward sloping, law of demand, the more expensive the good is, the lower the quantity I'm willing to buy. Right? So supply curve, demand curve. And then the intersection of that, as we've said, that is the equilibrium point, the price of which is what we call the equilibrium price. Again, that's just the horizontal. And then the quantity, or the vertical, is called the equilibrium quantity. Okay? Now, we've also talked about in lecture 2 of this module that sometimes there are things that, that can shift supply and demand. So, for example, if we shift supply to the left, we do this, right? So we get a supply curve and then we move it to the left. How far from the left, that we can't really say. It depends on various factors, depends on the numbers. But again, we're here for the concepts. Now, the new supply curve will intersect with the old demand curve because the demand curve hasn't shifted, and we have a new what you call this? We have a new equilibrium point, right? Which we'll highlight in gray. And again, that will give us an original price, which is the original price of the original equilibrium price for the old supply and demand curves meet, and we've got the new price, which is where the new supply curve meets with the demand curve. Okay, and of course, same way, there's also the original quantity, and there's also the new quantity. And as you can see for here, we see that when the supply shifts to the left, the price goes up, right? The price goes up, but the quantity goes down. Okay. Okay, that was done for the recap. Now, what we can see right now, so we know when the supply shifts to the left, we just saw that in the previous slide, price goes up, quantity goes down. That's clear enough. However, there's also another, elasticity has actually asked this question: how much does it go up, and how much does the price go up, and how much does the quantity go down? Okay, so that's what we'll be focusing on right now. And as you can see, the shape of the demand curve matters. So for example, let's have our supply curve again, and let's have our shift in supply. So this is the exact same shift. It's the exact same supply curve. How do I know? When I did the slides, I copy pasted. Okay. But now let's imagine our demand curve is a lot steeper than the previous one. So as you can see, this one's a lot steeper, right? It goes down really quickly compared to this one. Now let's look. So our original equilibrium will be here. Our new equilibrium will be here. Now let's have a comparison. Let's look at price first, right? So if we look at price, so let's draw price, the horizontal line for price on the original. And now let's draw the same line. As you can see, again, I've copy pasted this, so they should align perfectly. Now, if we look at the new equilibrium, in our less steep demand curve, you can see that it's over there. It's higher, of course. So we know it's high, price goes up, right? And then for the steeper curve, we see price goes up as well. But look, it's much higher. You can see that distance over there. I'll draw an arrow, right? And you can see this distance over here. So as you can see, with the slope being steeper, the change in price is actually a lot higher. But how about the change in quantity? Well, let's draw those lines as well. So we draw that vertical line for the equilibrium quantity. We'll draw that vertical line there as well. And then we'll draw that for the new equilibrium. And as you can see, for the steeper slope, as you can see here, I can't even draw these arrows anymore because they can't fit anymore. The change in quantity is a lot lower, right? The change in price, the steeper the demand curve, right? The change in price is a lot. There's a lot more change, but the change in quantity is a lot less. Okay, I'll show you another example. Now, let's say this time I've got a less steep. Let's say it's almost flat, right? So almost flat. So we draw original equilibrium again and our new equilibrium. Now let's draw a line for the price. A new one. As you can see, the distance that the price changes here is still the same as the original one. Now, as you can see, if the curve is a lot less steep, you can see that the distance here is a lot smaller. So the price doesn't really change a lot. But what happens to quantity? As you can see, we draw vertical lines again. The quantity for this one is a lot bigger, right? So if the slope is a lot, if the line is a lot less steep, it's a more flat. A small change in price means a large change in quantity. Okay, so you can see from this one, the demand curve does matter. The shape of the demand curve matters. It's not just the amount of shift. Just remember, the shift in the supply curve has always been the same. The only thing we change right now is how steep the demand curve is. Okay, so that's just to show you how the demand curve matters. Now, I will have to apologize for the next following slides because we now need to quantify how this all works. So, I have to apologize a bit because we will be doing a little bit of math. Sorry. Yes. Don't worry though, it's not going to be as hard as limits or calculus and all of that. It was just that Mean Girls was the first thing I could think of that had maths in it. Okay? And on Wednesdays we wear pink. Okay. So we'll talk about some maths. Alright, so we'll talk about what we call relative change or percentage change. Okay? So basically, a relative change or percentage change is this concept, and it's not just unique to economics. I think it actually came from physics. A lot of the stuff, by the way, if you haven't noticed, a lot of stuff in the equilibrium module are terms that we've borrowed from physics. I mean, even the word elasticity and equilibrium, those originally came from physics. Okay, so economics does borrow a lot from the sciences. Anyways, so basically, relative change or percentage change is how a quantity changes as a percentage of its initial value. Mathematically, it's like this. Woo! What is that? Okay. Okay. Basically, here's a simple explanation for this. Okay. So for the math people over there, if you want the formula, that's it. But we'll do it one at a time, so you don't actually have to think about it as like this scary thing. So basically, if a number changes, okay, we get how much it's changed and divide that by the original number. Okay, let me show you a simple example. Okay, so example 1. Let's go for a simple example. So x changes from 4 to 6. What is the percentage change? So keyword here, change and percentage. So the first thing we're going to do is to find out how much is changed. And of course, right, So, first question, how much did x change? And now, if you're familiar with your physics or chemistry or anything in maths, um, though this symbol over here, that's the Greek letter delta. Delta x basically means what is the change in x. So, how much did x change? Right? So from here, from 4 to 6, like how much did it have, like how much did it change? So basically, that's just final minus initial value. Okay? So the 6 is, that's the final value, right? Minus the initial value, which is 4. We subtract that and we get 2. I hope that's clear. So delta x, or the change in x, is delta is 2. Now, that's for change. Now we call percentage. So percentage just means what percent of the original quantity. We always talk about the original quantity is the change. So what's the percentage of, what percentage of 4, what percentage of the original quantity is our change, which is 2, right? So divide this change by the original value, and again, here's the mathematics behind it. So it's delta x over x, but for you, if you want, it's just 2 over the initial value. So our, what's the difference? And then we divide that by the initial value. Okay? So initial value is 4, 2 over 4. We can simplify to a half, or if you want, 50%. Okay? I hope it's clear. I hope so, because yeah, well, I'll give you 2 more examples. This time with economic stuff. Okay? So example 2. So let's say a store used to sell 500 toothbrushes a month. Now it only sells 300 toothbrushes a month. Calculate the percentage change in the quantity of toothbrushes sold. So, first of all, let's identify what's our final and what's our initial. So, they used to sell 500 toothbrushes, so that's our initial, right? Because they initially sold 500. Now, they only sell 300, so that's our final. So, first step that we have to take, so how much did the quantity change? How much is the, what's the difference between the final and the initial? So it's always the final at the end minus the initial. So our final here is 300, right? So that's just the mathematics. Final minus initial. And again, delta Q for you people who love maths over there. Delta means, again, it just means change, and Q is quantity. I know, not really imaginative, isn't it? So the final, again, the final one is 300 because that's what they're selling at the end. And our initial is 500 because that's what they used to sell. And 300 minus 500 is just negative 200. Okay, so that's for the change. Now let's talk about percentage. So negative 200 is what percent of the original, which is 500, right? So divide this change by the original amount. That's the second step. So our change is again negative 200, right? And the initial amount that we have, the initial quantity is 500. So we just divide negative 200 by 500, and that will simplify to negative 2 over 5, and percentage-wise, it's negative 40%. Is that clear? I hope it is. But just to drill it in, I'll give you one more example of percentage change, okay? Example number 3. This time we'll talk about price. Now, the price for renting a tennis court for an hour used to be 10 pesos. Now the price is risen to 11. Calculate the relative change in the hourly price of renting the court. Okay, 2 numbers. Which was the initial, which was the final? Well, again, this relies on your ability to understand sentences. Okay, so I'm sure you'll be fine. Okay, so it used to be 10. It used to be 10, right? So that's the initial, because it used to be, that was before. Now this price has risen to 11. So the final price is 11. So final, initial, first step, calculate the change. So calculate delta P. And again, this is just final minus initial. The final is 11. The initial is 10. Subtract that, we get 1. Okay? Clear. Next. So the difference now is 1. We divide that by the original price. And again, the original price used to be 10, right? So 1 over 10, we make that into decimal notation, or percentage notation is 10%. And by the way, relative price or percentage price, it doesn't matter whether you express this as a fraction, as a percentage, or as a decimal. It's your call. It's, for me, I prefer percentages because it says percentage change, so why not? Okay, or relative change, they're all the same, okay? And just a note for the rest of you who would want to pursue sciences, relative change is really important when you're measuring errors, okay? Because a lot of stuff when it comes to measuring errors, measuring experimental errors rely on relative change. So this is not only a topic in economics. Again, this is something that we borrowed from the scientists. Okay, so just as a note, relative change and percentage change is a very important concept. And usually, this is not how we introduce elasticity. Okay, it's just the fact that I want to give you guys a piecewise way into this. So I'm giving you 3 examples. I hope that's clear. If not, feel free to rewind the video again so that it is clear, okay? Because we're gonna be needing this to actually explain what elasticity is. All right. So let's do a case study of earphones. Okay, so we'll be using relative changes or percentage changes again. So here's another example for all of you. So consider only the demand curve for earphones. So we'll only be talking about demand, we'll not talk about supply this time, okay? So quantity again, and then we got price. Let's use pounds for the currency. Again, doesn't really matter. We're here for the concept, right? Okay, so that's our demand curve over there. So we don't have supply curve. So what happens if the price of earphones changed from £7 to 10 pounds, 10 quid? All right, so what happens to earphones, okay? Now, again, this is an arbitrary demand curve. I just drew that. So let's just say it's like 7 quid is over there, £7, sorry. So let's say, yeah, seven pounds is over there. And of course, that hits the demand curve, right? Let's put an X over there, and that gives us some sort of quantity. Let's say it's 2,000 earphones. Now, if we increase the price, let's say it's a tenner, a tenner, that's going to hit the demand curve again. And again, law of demand, we increase price, we decrease quantity. And let's say the new quantity is just 1,000. Okay? So we got 4 numbers over there. Now let's have a look. First of all, let's calculate the percentage change in price. So that's percentage delta P. Okay? So percentage change in price, let's see. So we'll only talk about price, so we'll only bother with these numbers. We won't bother with them 2 yet. Okay? So we'll only bother with these 2 numbers. Now, we calculate first delta P, which is again the change. You know, it's quite helpful, the notation for this. Percent change in P. I know, it's nothing creative there, to be honest. Yeah, so we calculate first delta P. So again, delta P is just final minus initial. The final price is 10, the initial price is 7, right? Because from 7 to 10, so final, initial. So delta P is equals to 10 minus 7, which is equal to 3. Now let's calculate the percentage. So we'll divide this 3 by the initial, which is 7, right? So 3 over 7, and then that's about 43%. You can leave it as a fraction if you want to, or you can make it 0.43 as a decimal. It's really up to you, but to be honest, 3 out of 7, that's it. Okay, so that's the percentage change in price. However, this is demand curve, right? So we also have quantities. So we can also calculate the percentage change in quantity demanded. So basically this is quantity. So again, we need 2 numbers. These are the 2 numbers. We won't bother with these 2 guys, right? Because that's price. And now we're just going to talk about quantity. So again, final minus initial. So the final again is 1,000 because at the final price is 10, and at 10 the quantity is 1,000. So we'll talk about that. So that's 1,000, and then the initial one is 2,000. So 1,000 minus 2,000, that will give us negative 1,000. Okay, I hope you're following on the maths. And again, we divide this by the original quantity, right, which is 2,000, and we divide that, so that will give us negative 50%. Okay, feel free to use your calculators, because why not? So yeah, so feel free. Anyways, so that's it. So let's summarize. So the percentage change in price is 43%. The percentage change in quantity is negative 50%. So what happened? Now, from the law of demand, we know, first of all, that the signs should be opposite to each other, right? So here we say that the percentage change in price increased by 43%. So in other words, the price increased. And from here, the percentage change in quantity, what happened? It decreased. It's negative, right? So there's a decrease in that. So quantity goes down. Law of demand. We know this already, right? Basically, what we've just done here is restated the law of demand mathematically. Price goes up, quantity goes down. However, what I want you to look at are the actual numbers. 43 and 50. Who's actually bigger? Okay, so we know 50 is much bigger. So what happens? The change in quantity, the amount that quantity goes down, right, is a lot bigger than the amount that price goes up. Does that make sense? So what we're doing here is we're comparing the difference between how much quantities changed compared to how much price has changed. So in here, quantity's gone down a lot more than price. So the law of demand, again, remember what I said from the demand lectures, the law of demand can only tell us whether or not that the shape, it only tells us that the demand curve has to go down. That as we increase price, we decrease quantity. However, now we can also tell using the concept of elasticity how much does quantity go down compared to price. So as you can see here, basically we're just comparing quantity versus price. In terms of absolute terms, if we make this positive, the decrease in Q, the decrease in quantity, 50%, is a lot bigger than the increase in price. Okay? So that's what we call elasticity. It's the comparison between what happens when I increase price, what happens if I increase or decrease price, how much more does quantity get affected? Does the amount that quantity goes down higher or lower than the amount that price goes down? That's elasticity. Okay? Now, now this is going to be a bit more mathy, and I'm really sorry. Okay, so comparing the percentage change in price against the percentage change in quantity is in a way asking the question: how big of an effect does changing prices have on the quantity demanded? So, if we change the price, what effect does this change in price have on the change in the quantity demanded, right? Because we know if we increase price, we're going to decrease the quantity, or if we decrease price, we're going to increase the quantity. But how much of an effect does that change? Does the price change have on Q? Because again, remember from the graphical thing that we saw earlier, some bits where a small change in price can mean a large change in quantity, and there are times when a very large change in price barely affects the change in quantity. It does change, but the magnitude is different, right? So it does change, but very tiny. Okay, so we got three cases. So it's a comparison between P and Q. So there's three cases, right? The first case is if the change in quantity is greater than the change in price. And now if you see the bars over there, that's what we call absolute value. Again, Matt, really sorry. Basically, I'll give it to you in the most simple way possible. This symbol means we just make whatever is inside positive. Because remember, right? Law of demand, if one goes up, one will go down. So one will be negative. And comparing negatives with positive, the positive will always win out. So it's kind of useless. So what we need to do is to make everything positive. Okay, so this symbol is only here not to confuse you. It's literally just a pedantic thing that says I want to make everything positive because I actually just want to see how much things have changed. Okay, I don't care about the direction of the change. I just want to see how much they've changed. Okay, so that just means I'll make things positive. Okay, so you can, if you want to not think about that, so you don't get scared, that's fine. Just remember, I'm just comparing positive against positive. Okay, whatever is negative, I'll make it positive. Okay. Now, if the change in the quantity is greater than the change in price, then what does that mean? If price increases, we know quantity will decrease, but quantity will decrease a lot more than the price increases, right? Because that's literally what this says. That the percentage change, the change in the quantity, the change is a lot bigger than the change in price. That's literally what this says. Okay, that's just a mathematical way of expressing this, and this is what we call an elastic good. Okay, this is what we call elastic. Okay, so if you kind of think about this, so again, we borrow this from physics. When you say elasticity or elastic, what do you think of? Rubber bands sometimes, right? I hope people still think of rubber bands. So elastic means, a small change in price. No, there's that's huge. And you know how rubber bands, you apply a small force and then suddenly the rubber band stretches out a lot, right? So in the same way, the price is like the force. We apply a small price change, the difference in quantity is big, so that's elastic. Now the other way around that, of course, is case two, where it's less, where the change in the quantity is a lot less than the change in the price. So again, we know price goes up, quantity goes down, but this time, right, who's bigger? Price is bigger. The change in the price is a lot bigger than the change in quantity. And again, this is just the mathematical way of expressing this. That if so if I have a quantity that's smaller, if a change in quantity is smaller than the change in price, then price is going to go up a lot more than quantity. And basically, we call this inelastic. So and again, just like not a rubber band, let's say a rock, you apply a lot of force into that thing's barely going to stretch, if ever. It's going to stretch microscopically, as any material scientist will tell you, but it's barely going to stretch. Okay, so that's elastic, inelastic. And again, it all depends on how responsive quantity is to the price. If the quantity changes a lot when we change price, that's elastic. When the quantity doesn't change a little bit, even though the price moves a lot, that's inelastic. So what's case 3? We got greater than, we got less than. What's the final sign? Equals. So this leads us to case number 3, where the percentage change in Q is the same as the percentage change in P. What that means is that when the price does rise, the amount that the price rises is equals to the amount that quantity falls. Okay, so we call this unit elastic. Okay, so this means that if you think about the force of quantity or price are equal. Okay, so that's what we call unit elastic. And just another thing, in mathematics, when we say the word unit, that actually just means one. So sometimes you might hear the word the sum is unity, or something unity or unit, that literally means one. Okay, so as you can see from here, and we'll see why this is going to be one. Okay, but as you can see, the price rises, the quantity falls, but the relative sizes are the same. Okay, and so let's summarize that. Okay, so again, if there's a change in price and the price move and okay, if we got a price movement, right, and that will give us a quantity movement. If the movement in quantity, if how the quantity changes is much bigger than how the price changes, that's what we call elastic. But if the quantity changes not by much compared to price, so let's say you've got a huge price, you got a huge increase in price, but the quantity change only changed by a bit, only went down by a bit. That's what we call inelastic. And finally, if they're about the same or if they are equal, that's what we call unit elastic. Okay. However, this isn't normally how we define elasticity. Okay, we define it in a bit more mathematical way. Okay, so bear with me for a bit. Okay, so there we go. Again, here's our cases. Now, if we divide everything by delta, by the percentage change in P, so we divide everything here. So what happens? First of all, if we divide this by percent change in delta P, we will have, right, we will have this fraction over here, right, that's just divided by delta P. And because we're dividing it by itself, that will be equal to 1. Right, so we now have this, and the same way for here, we got the fraction, but that will be less than 1. We just follow the sign. And for this one, it will be that. And notice that for unit elastic, that's equals to 1. And remember what I just said. Unit means 1. So that's why we call it a unit elastic, because 1 is think of it as 1 is the basis for whether something is elastic, inelastic, or unit elastic. And now, together, we can actually give this a name. So without the absolute value, without these straight lines over here, this fraction over here, we could give that a name, okay? And we could call it E. And this is what we call elasticity, okay? So literally, when you see the word, specifically price elasticity of demand, what that just means is that what is the percent change in Q over the percent change in P? In other words, how sensitive is the quantity to price? That's all it says, okay? Despite all the mathematics you see here, it's literally just how does the quantity get affected by price, okay? And so here we are again. I'll just put that in a box, and this is the definition of the price elasticity of demand. This is the mathematical definition. But again, it literally just means how is quantity affected by a change in price, okay? And so we could rehash that. So this whole thing, we could change that into E and put an absolute value. So now we could say that if the absolute value of elasticity is greater than 1, and again, as absolute value just means, because this is going to be negative, so because this one of these are going to have opposite signs, right? So one will be negative, one will be positive, and a negative number or a positive number, negative number divided by positive, or positive divided by negative, will give us a negative number. Now we just want a positive value, so that's again why we put the bars in, because that means just take the absolute value. Now, if that absolute value is greater than 1, if the positive thing is greater than 1, then that is elastic. And again, equals 1 unit elastic, less than 1 inelastic. And you can think of this, and I got this from a book from Frank and Bernanke's Principles of Economics. You can think of this as a number line, where this is the value of um, E, that's positive, elasticity, we made the elasticity positive. And if it's in between 0 to 1, then we have an inelastic good. If it's beyond 1, we have an elastic good. And if it's exactly at 1, we have a unit elastic good. Okay? And of course, the further away we are from 1, we say the more elastic the good is. And the further away, the closer we are to 0, the more inelastic the good is. Okay? So we use elasticity to measure the effect of one quantity on another. And this is not just for price and quantity demanded, okay? So you can have a price elasticity of supply. How does the quantity supplied get affected by the price? And again, it's the same. So that will just be the percentage change in the quantity demanded supplied over the percentage change in the quantity in the price of the good. And we also have so many other things. We have income elasticity of demand. How does demand change depending on people's incomes? Okay, and all of that. So in general, we just say this is X. If we have in general, and again, it's more mathematical. But again, just remember this. This just measures when you see this here, it just measures what is the effect of a quantity y on x. If I change the price, let's say, how does that, if y, let's say, if y is price and x is, let's say, I don't know, quantity, if I change the price, how does that affect the quantity? If I change y, how does that affect x? Okay, and that's all there is to elasticity. And later on, and if you decide to take an economics course in university, you're gonna find out more elasticity, more about elasticity. You're gonna find out different measures of elasticity. Okay, but for the scope of this lecture, we'll end with we'll stop with that definition of price demand. Okay, price and quantity demanded. Okay, so let's get on to a definition. So some notes bits. So and again, this is basically what it is. Elasticity is it measures the response of one quantity to another. We measure how quantity responded to price. That's what it is. And the price elasticity of demand is just that. It's the elasticity of price of the quantity demanded of a good with respect to the price. Okay, so that's what I've been battering on. If the price changes, how does quantity change? So I'll give you one example, and this will be example 4. Just to show you how we calculate the price elasticity of demand. Now, we've already done that with the headphones example, but let's drill it in, shall we? So here we are. This time we'll be talking about the quantity, which is in kilowatt hours, because that's usually how we measure electricity. And of course, let's say the price is in cents per kilowatt hour. So let's draw our stuff here. So let's say at the price of 30 cents, we will be consuming 700 kilowatt hours. And the price of 50 cents, we'll be consuming, let's say, 650 kilowatt hours. All right. So the question is, we calculate the price elasticity of demand of electricity if the price decreased from 50 cents. So this is our initial value, and all the way to 30 cents per kilowatt hour, and determine whether it is elastic, unit elastic, or inelastic. Okay, so this is our initial quantity, and this is our final this initial price, this is our final price, and this is our initial quantity, and this is our final quantity. Okay, initial, final, initial, final. All right. So the first thing we need to do, remember, price elasticity of demand is basically the percentage change in the quantity divided by the percentage change in price. Now let's just take it one step at a time to make things easier. So let's first find out what the percentage change in quantity is. Okay, So let's do that. So first thing we need to do is, again, delta Q first just means the change, right? So that's the final minus initial. So, and that's the whole definition. Final minus initial divided by the entire thing. And I'll just do this in one fell swoop. So the change first, final minus the initial value divided by the initial value. Okay, so that's what we do in one fell swoop. If you want, you could do it one at a time. 700 minus 650 first. That will give you 50, then 50 divided by 650. Or if you have a calculator and you want to just do it in one line, that's also one way to do it. Okay, but again, it's just the same step. We take final minus initial, then after we get the answer, we divide everything by the initial. And so that gives us about, if we grab a calculator, so it gives us about 7.69%. So it hasn't moved much, hasn't it? It's only moved by 7.69% of its original value. So now we go to the second thing, that second relative percentage change or relative change that we want to calculate, which is price, right? It's in the name. So the price. So we'll calculate again percentage change in price, and it's the same formula. We subtract the final from the initial and then divide by the initial. So this is our, again, from 50 to 30. So that's our initial, that's our final. So same formula. We get final minus initial first. So final minus initial divided by the initial. So that's the formula. And again, you could do this one step at a time. You could subtract 30. You could subtract 30 minus 50 first, and then divide by 50. Or if you want to do it in one fell swoop, you could do it that way. And bring out our calculators, we get negative 40%. Notice this is negative. The quantity is positive because we have a decrease in price, which means the quantity demanded will increase. Okay, so that's our value there. And so now we can calculate the price elasticity of demand. And that's just quantity over price. And we've already gotten the value for that, and we've already gotten the price for that. And don't worry about those bars. Literally, we just make anything in there positive. Okay? So that will be, we know, 7.69% for the percentage change in quantity and negative 40% for the percentage change in price. So we put that in, and then we divide these two, and that will give us around about negative 0.19. We take the absolute value of that, which means make it positive. We get 0.19, 0.19. And again, so now the question is, so we've determined the elasticity. Now the question is this elastic? Is this unit elastic, or is this inelastic? So we compare this value to 1. How far is this less than 1, equal to 1, or greater than 1? So as you can see, this is less than 1. It's a decimal. So if it's less than 1, that gives us inelastic. Okay? I hope that was clear. And that's how you calculate the price elasticity of demand. Okay? Now, we'll move on to one final example, and then that's it. And we'll go back to ivory, elephants. So, what's the actual main effect though of this having different elasticities? So, what is the difference between an inelastic good and an elastic good? How differently do we behave in that? Okay, so consider this. Ivory is a relatively inelastic good. Okay, so from this paper, the price elasticity of African elephant poaching, we see the price elasticity is 0.4, which is quite low. That's quite inelastic. How about leisure travel is an elastic good? Okay, and here's some of that. Some of it is inelastic, but for most of it, right, it is actually elastic. So what happens when the price for these goods change? So elephant poaching, so ivory is an inelastic good, whereas leisure travel, that's an elastic good. So what is the difference in how we treat this? And the sad reality here is, in elastic goods, again, if we change the price, right? The characteristic of an inelastic good is, if we change the price, if the price goes up even by a lot, the quantity demanded doesn't go down a lot. Okay, so that means, so for something like elephant poaching and all of that, even if we have measures to stop to prevent poaching from happening, what's going to happen to price? It's going to increase, right? The reason why we try to stop these illegal activities, right, it's to make things harder. So the price of getting it is much higher. The price of getting ivory is much higher. However, because it's inelastic, that won't actually deter poachers from actually doing it. There will be less poachers, right? Low demand. However, the decrease in poaching isn't that much. Okay, and so that's the sobering thing. Whereas, for example, in leisure travel, if we have a small change in price, even just a tiny bit of change, if the price increases by a small bit, then what happens is the quantity demanded just goes down a lot. Okay, again, this is elastic, right? As you can see, especially for something like intra Europe short haul travel, as you can see, that's really elastic right there. So it's really responsive to changes in demand. And so, for example, with the rise of COVID-19, prices for airlines had to go for leisure travel had to go down, and a lot of airline companies, especially those that dealt with leisure travel, especially within Europe, went bust. Okay, why? Because even just a small price change, price increase, suddenly no one wants to fly anymore. So there's a difference between an inelastic good and an elastic good, and it's the fact that with elastic goods, because of how sensitive the quantity is to price, things can go bust really easily, or it's easy to discourage habits, discourage a behavior. Whereas for inelastic goods, it's really hard. However, there is a small light though, with artificial ivory coming in. So one of the things that determines the elasticity of a good is whether or not close substitutes exist. So lately, with the rise of technology, we can make artificial ivory, and so that's actually um, put the elasticity of that's increased the elasticity of ivory. So that means we can actually see that measures to stop elephant poaching might actually help to deter that behavior. All right, and this always gives you some. I mean, economics sometimes is a sad subject, but in the end, there's always a bit of hope, and mostly that hope lies with new ways of doing things, new technologies, and just making an informed decision about things. All right. Now there are other questions in elasticity. Usually in elasticity, you can create a whole module on this, and there's all these questions. Okay, so a bit I touched on is what determines the elasticity of a good. And I won't address these questions. If you're interested, feel free to grab an economics textbook. There's plenty available. Um, and I won't fully touch on these. Okay, so one thing I've touched on was um, people's incomes determine an elasticity of a good, but most importantly, substitutes. If there are substitutes nearby, people will most likely. Um, it's easy to replace the good, so if a price changes, I can switch on. It's easy to switch, so that determines elasticity. So how do we actually measure the demand curves and hence the elasticity of a good? And again, this is later on when if you have ever do a microeconomics course, you'll learn all about how to measure demand curves and supply curves. So does one good have one elasticity, or are there more? And I've already said there's more than one type of elasticity. Okay, there's elasticity demand elasticity with respect to demand to income. There's elasticity of supply with respect to price, and so much more. Yeah, and what other elasticities are there exist? I just mentioned that. And what does elasticity mean for business? So we haven't fully delved into it, but with example 5, it does say that sometimes when goods are more inelastic, it's better for businesses because customers are not sensitive to price changes. So I can jack my prices up, and my loss in customers isn't a lot. Okay, so these are other questions that you will be encountering if you ever choose to continue your study into economics. But for now, that's what we have. So thank you for listening, and I hope to see you all, or hope to hear. I hope maybe you hear from me very soon in whatever other modules that I might be doing. All right. So thank you, and again, some image credits.